Okay, this video covers, I'll try to cover two sections. Let's see if we can cover section 9.5 and 9.6 in the same video. Section 9.5, equations with radicals. So we're gonna see how do we solve a radical equation. A radical equation is an equation. Of course, you're gonna see an equal sign in the expression. And the variable, unknown variable x, is going to be under a radical, is inside the radicand. We talked about this before, right? N is called the root number or index of the radical, and the star, whatever under the radical symbol, that is called a radicand. A very important concept. Radical equation simply just is just an equation with the variable x in the radicand. On the notes, we can see the notes. Again, the notes is posted in Moodle from the very beginning of the semester. Let's see the guideline for solving a radical equation. We have 5 steps in the guideline. You can find it in the notes again, by the way. So number 1, step 1, isolate one of the radicals on one side of the equation. An equation may have more than one radical. Step 2, raise both sides of the equation to the power corresponding to the index of the radical. Index of the radical is the root number of the radical. Step 3, if the equation still contains a radical, repeat step 1 and step 2. If we only have one radical in the equation, then you don't have to repeat. Step 4, solve the equation after all the radicals have been eliminated. Step 5, check all your proposed solutions in the original equation and eliminate any extraneous solutions. Last step, step 5, is very important. We're going to explain why it is mandatory to check your result when you solve a radical equation. We're going to apply this guideline, the steps, the procedure, on example 1. So let me copy example 1. Example 1 only has, let me get a problem. Example 1 only has one radical in the equation. It is square root. The root number is not written out. That means it's default as 2. This is a square root. This radical is a square root. The root number or index is 2. The radicand is 3x plus 4 equals 5. Okay, so we're going to solve this equation as example 1. This equation is a radical equation. It is an equation and the variable x is in the radicand of the radical. Yeah, how many radicals do we have in this equation? 1, right? You only see one radical here. Let's go over the guideline that I showed you earlier. Step 1, isolate one of the radicals on one side of the equation. We only have one radical, and it's already isolated on one side, on the left-hand side of the equation. So we can skip step 1. Step 2, raise both sides of the equation to the power corresponding to the index of the radical. Yeah, what is the index of the radical? What's the index of the radical? You don't see anything here. As I said, it is defaulted as square root, so the index is 2, right? The index actually is 2. So by the second step, we are going to, step 2, we are going to raise both sides to the power of 2. Equation is like a scale, right? left-hand side, right-hand side. As long as you treat the both sides, you treat both sides the same way, the scale would keep the balance. So we raise both sides of the equation to the power of 2. 2 is the root number or index of the radical. So that's step 2. That's what happened after this. The square cancel out the square root. Squaring and taking square root, they are inverse. Remember we talked about this at the beginning of the chapter 9. So square and square root cancel out. We have the left-hand side becomes 3x plus 4. Right-hand side, square of 5, 25. And we have a very simple linear equation now. Let's solve this linear equation for x. I'm going to apply my transposition of terms. I always try to sell my technique. This technique is very useful and convenient. So we're going to move 4 over. Positive 4 becomes negative 4. We move it over because we want to combine them. We cannot combine two like terms if they are on different sides of the equation. 25 minus 4, 21. Divide both sides by 3. Okay? Because 3 is the coefficient of x. Coefficient of x means the operation between 3 and x is a multiplication. In order to reverse the multiplication, we need a division. Okay, we need a division. So we divide by 3. We divide by 3. And those 3 cancel out. We have x isolated on the left-hand side. We have x equals 7. 21 divided by 3 equals 7. That's step 4, actually. Solve the equation. After all the radicals have been eliminated, we solved it, we got x equals 7. The last step in the guidelines, step 5, we need to check all our proposed solutions. How do we check? We will have to plug the proposed solution back into the original equation. Let me change the color. Let's use blue. So the original equation is square root 3x plus 4 equals 5. Let's plug in the proposed solution x equals 7. After we plug in, if we have a true statement, means 7 satisfies the original equation. Of course, 7 is the actual solution. Otherwise, if we plug in, we got a contradiction. That means 7 is not the actual solution. It is extraneous. We plug in square root 3 times 7 plus 4 equals 5. Square root 3 times 7, 21. Square root of 25. Square root of 25, this is the principal square root of 25, which is 5. We end up with a true statement. So that means 7 is not extraneous. 7 is the actual solution of the equation. So we can make a conclusion. Thus, the solution set of the original equation is a set containing one solution only. The solution is 7. Solution is 7, okay? Solution is 7. Let me explain why would we possibly have an extraneous solution. And why do we need to check? Extraneous. Why would we have? We might have extraneous solution. It's because, look at the original equation. This is square root. The root number is even. So the radical must be bigger than or equal to 0, right? 3x plus 4 must be bigger than or equal to 0. We have this restriction in the original equation. However, when we square both sides, when we removed the radical, we also removed the restriction. You know what I'm saying? So that might invite in possible possibly invite in extraneous solutions. So we're going to be very careful. You need to remember, when we solve a radical equation, we need to check to see if the proposed solution an actual solution. If it's extraneous, if the proposed solution does not satisfy the original equation, we have to get rid of it. Let's look at example 2. Example 2. You know what? Actually, I want to challenging you a little. What if the equation here? Let's go back to example 1. What if the equation is square root 3x plus 4 equals a negative 5? Okay. What if the equation is the square root of 3x plus 4 equals a negative 5? And how do you solve this equation? This actually is a very simple equation. Left-hand side is the principal square root of 3x plus 4. Right-hand side is a negative 5. You can pause it before you see no solution. Yeah, this equation has no solution. Why? Because there's not possible for a principal square root be a negative number. Do you see that? And this actually is a very simple equation. You don't have to do nothing. You can determine without solving it. You don't have to apply the whole procedure. What if the equation is square root 3x plus 4 equals 0 though? Could a principal square root be 0? Yeah, you can pause here and think, and then continue to see the answer. The answer is yes, it could be, but the only quantity has a principal square root 0 is 0 itself. So we have 3x plus 4 equals 0, and we solve this equation, we have x equals negative 4/3. So that's the solution of the equation. Okay, so this is just something extra. I didn't include them in my notes, but they are also important. This is a case, this is another case. If the right-hand side is a negative number, no solution, because it's not possible for a principal square root be negative. If the principal square root is 0, then you simply would have the radicand equals 0, and you solve it. All right, let's see example 2 now. The equation is square root of x plus 5 equals x plus 5. All right, we're going to apply the guideline again, okay? We're going to apply the guideline again. How many radicals do you see? One radical only. And what's the root number of the radical?